Okay.
So I guess everyone can see us now.
So, perhaps. Hello, everyone. Hello. Welcome to the Math Kangaroo live solve. I'm not sure if you can see me. Maybe you only see an OBS screen, but either way, hello and welcome. Yeah. Alrighty. Oh, I'm glad to hear
Uh,
that you guys can hear me.
I
All
can
right.
I can
Hello.
see you.
Oh, that's awesome. Alrighty. Well, welcome to Math Kangaroo, the live solve, and please hold for a few moments while we iron out a couple of things. But for now, as Chat Relay is saying, well, clearly some of you have figured out how to get your messages to appear on screen, and that's by sending it to the person in Zoom named Chat Relay. So please continue to do that as you answer our icebreaker, which is, where are you from? Yeah. Alrighty. Yeah.
Hi everyone. I just also wanted to say hello real quick. I'm curious. This is my video putting on for everyone at this point? Evan, do you know if my video is putting on at this point?
I'm not sure. I think we're approximately being put through, but I think right now it might just be the OBS being put through, but they can definitely
Oh,
hear us. So
okay, that sounds good.
yeah.
I see that we're still working this out.
Oh, we're through.
Are we through?
Yes, completely.
Yes, okay. Then maybe I'll just go and quickly say hello. Right, and I wanted to welcome everybody. First of all, thank you, Evan, for already saying hello to everyone. But yes, I'm currently actually coming in from China. So in fact, I'm not going to be able to do the live solve directly with writing myself. But that's okay, because actually we have some incredible co-stars for today. But I just wanted to always acknowledge, first of all, thank you everybody for coming in. Happy New Year. And Math Kangaroo, we're very, very happy to collaborate with them because their questions are really, really good. The first time I ever saw their questions, I thought, wow, these are not like the usual math contest questions. And that makes it even more interesting. So today, we're happy to do levels 7 and 8, which is actually the sweet spots right there, right in the middle of middle school. And with that, I'm going to turn it back over to our co-stars. Evan, go for it. Back to you.
Hello, everyone. Yes, as Professor Lowe says, it's so good to see you, and we're really glad you're here. And through chat, I saw that you guys are coming from all over the place, which is awesome. We love to see that. And yeah, hopefully everyone will have an awesome time today, like Vera and Edison. And in case some of you have just joined, I want to take a brief moment to explain Chat Relay. For the messages to appear on screen, like Vera, Edison, and Betty's message, oh wow, two people from Canada. That's pretty cool. But anyways, in order for your messages to appear here, well, you should send your messages to the person in Zoom named Chat Relay, and they will put them through onto our screen and then add stars if they're good messages. And well, send good messages. We don't want to find out what happens if they're not good messages. Awesome. Well, this is interesting. We have very many people from Canada. This is pretty cool because I also am a pretty big fan of the National Hockey League. So Canada is great. Yeah. And I'm actually here today with my co-star, William. William is a rising sophomore at Lexington High School, one of the best high schools in America. He's the 2022 Math Counts state champion in Massachusetts, which means that he was the best person on the Math Counts competition in the whole state of Massachusetts, which is awesome. He's also achieved a perfect score on the AMCA in 7th and 8th grade, which is a very impressive mark on a national competition. And he's qualified for the AMY, another national exam, since 6th grade. And to top it all off, he's qualified for the USA Junior Math Olympiad in 2022 and 2023. And apart from math, William has other incredibly impressive interests, including cybersecurity, things like capture the flags, and solving Rubik's Cubes, playing card games, and also playing with his dog, which is really awesome.
And Evan, on the other hand, he has also qualified for the USA JMO since 9th grade, actually. And unlike me, he qualified for the USFO. And he also did the US NCO NAS since 10th grade. He was a 2 times Math Counts NAS qualifier, and he was the Nevada Math Counts state champion. And in addition to all of that, he is also the co-president of his school's math club, which I think is really cool. And in his free time, he likes to do 3D modeling and printing. He likes playing the viola, and for some reason, he likes eating bagels. Uh, I'm not a big fan of bagels, but
It's
yeah,
horrible. How could you say such a thing? I'm personally hurt. Oh no. That's very
I'm
sad.
sorry.
That's okay. I'm just joking. I see Betty loves bagels, which is the correct answer. Yeah. Oh, and she also likes 3D modeling. How cool. So, William, what do you say we jump right into the Math Kangaroo problems of the day?
Okay, yeah, let's not talk about whether bagels are good or not. Let's talk about math instead. Which of the shapes below cannot be divided into 2 trapezoids by drawing a single straight line? Um, so we have a triangle, a rectangle, a trapezoid, a regular hexagon, and a square. So, Evan, what do you think we should do?
Hmm. This is an interesting question, that's for sure. But I know right away that, well, we can definitely divide a rectangle into 2 trapezoids by drawing this line, and the trapezoid into 2 trapezoids by drawing that line across. We get 2 trapezoids in both of those cases. I don't know. After a bit of thinking, I don't know how to do it with the triangle, so maybe we should move on and try some of the other answer choices. What about the hexagon and square? Can we divide them into trapezoids?
I think for the regular hexagon, all right, so a lot of people are already saying triangle. So, and I'm assuming that they probably, yeah, a lot of people are getting A. So you either cannot just find a way to divide the triangle into 2 trapezoids, or you probably the easier way is to divide all the other shapes into 2 trapezoids. So D, you can actually draw this line, right? There you go. So this is a trapezoid, and this is a trapezoid, and E is a square. If you're really lazy, you could just say that square is a rectangle, then you divided a rectangle into 2 trapezoids. But you can also just do it again, like a normal person. Uh, Here, and then the answer you'll get is A. You're not going to be able to divide a triangle into 2 trapezoids, just because you know that you can divide the other 4 into a trapezoid, 2 trapezoids.
Yeah, nice. And everyone in chat has gotten this as well. So, yeah, well done. That was fun. But onwards to question 4, which is Pranav is writing numbers on the vertex, on every vertex of the rhombus shown. Okay, I see a rhombus, and I assume Pranav is going to write numbers on these vertices. So that's good. He wants the numbers at the 2 vertices at the end of each edge to be equal to the number written on the edge. Wait a second. He wants the sum of the numbers at the 2 vertices of this edge to be equal to that number on the edge. Perfect. So we want to know the number he writes for the question mark. Ooh, interesting. I see. Well, one way to solve this type of question is just to, well, fill in the blanks of what he would write in the vertices. So we could say A goes here, B goes here, C goes here, and D goes here. And the reason I do this is because we're going to be able to get lots of equations involving A, B, and C. You know, A plus D is 8, A plus B is 9, B plus C is 13. And hopefully we'll be able to do some algebra stuff in order to eliminate A and B and end up with C plus D. So hopefully, since I see a growing consensus in chat with 12, hopefully we'll get D plus C equals 12, but let's find out for sure. And I see William already has the equations written, so take it away.
Okay, so when I look at these equations, I see that you want to try to get C plus D at the end. So maybe you could like manipulate these equations in some way. So we want to get rid of the A's at the end, right? There's no A in our final equation. So what if we subtract the third equation from the first? You'll get B minus D is equal to 1. And then you want to get rid of the B as well. So you can utilize the second equation and I'm just going to rewrite this as d minus b equals -1. It'll be slightly easier. B plus C plus D minus B is equal to C plus D. And then when you add the two right-hand sides together, you will get 12. So that is going to be our answer, B. And if you did not see this, instead, you can notice that um, from this, you can see that C is 4 greater than A because 13 is 4 greater than 9. I mean, 13 is 4 greater than 9. So then this edge should be 4 greater than 8. So that's just going to be 12.
Yeah,
And
that's pretty neat.
okay, so a carpenter wants to tile a floor of dimensions 4 by 6 using identical tiles. Which of the following tiles cannot be used? So I think this is like the first question where you could just try all of them, right? So A definitely works because you can have like a 2 by 3 grid of these chunks, right? And then if you do B, you'll probably struggle a little. Uh, yeah, I cannot find it right now, but so let's go back to that later. C, you can use these little L pieces to make a 2 by 3 box every single time. Oh, it actually is okay, yeah. So you can make this 2 by 3 box every single time, and you do this 3 more times. So C is possible. D is hold on. Oh, actually, I think oh B is possible. Oh, hold on, my bad. All right. So to do B, you want to do this. You can fill out the 4 corners like this. And then you can fill out this 2 by 4 box in the middle. So that's how you do B. And what's funny is that D is like a little different from the rest of the pieces because it has 5 slots, I mean 5 cells instead of 4. But the thing is we need to do a 4 by 6. We need to fill out a 4 by 6 grid, which is not a multiple of 5. So D is actually impossible. And E is also possible. So yeah, the answer is D, not B, my bad.
Okay. Yeah, that was a great realization. And I even saw some people mentioning in chat that, well, you can't divide 24 by 5, so obviously D will not work. And also, I don't think we mentioned this yet, but this is actually the first time both William and I have seen these problems. So we haven't taken peeks ahead of time. You get to see us live solving our way through them, hence the name Live Solve, which is pretty fun. But anyways, now instead of what were we doing in the previous question? Tiling a room. Okay, so we finished tiling our room and we're taking a break by crashing cars into people. Huzzah! Now, the diagram shows the initial position, direction of travel, and how far 4 bumper cars move in 5 seconds. And we want to know which 2 of the cars will collide. Interesting. Well, pretty clearly, after 5 seconds, car A will be here, car B will be here, car C will be here, and car D will be here. And they're not going to collide. They've just gotten closer together. So let's see what happens after another 5 seconds, maybe. Well, I know that car A, well, it went 1, 2, 3, 4 to the right and 1 up. So it'll go 1, 2, 3, 4 to the right and 1 up. Car A ends up over here. I should have color coded these, but that's okay. You guys have good eyes. You can see where I'm pointing. So car A ends up here. And oh, that's funny. Car C went 2 down in the first 5 seconds. So in the second 5 seconds, it'll go another 2 down and also end up in the same spot. So boom, A and C collide. Fire flames in exchange of insurance information and increase of insurance premiums. And also answer choice B, just as people have been saying. This is awesome. Well, it's not awesome that they collided. Although it is bumper cars, so maybe it is awesome that they collided. But either way, what is awesome is that we got the correct answer, yes, we did, of B, cars A and C colliding. Fun.
Okay, next question. that is hilarious. If Vito wants to write the numbers 1 to 8 in the boxes of the grid shown, so that the sum of the numbers in the boxes in each row are equal, and the sum of the numbers in the boxes in each column are equal. She has already written the numbers 3, 4, 8, and you want to see what is the number she writes in this box. I don't think you guys can see if it's actually shaded, so I'm gonna mark it in yellow. You're trying to look at the number that's in this box. So you have the numbers 1 to 8 written out once every time. So what if we look at, we need to find the sum of the numbers. We need to find the common sum of the columns and the common sum of the rows. So first, it would probably help to find the sum of 1 to 8. This is equal to 36. And then because the rows have the same sum, that means that 2 rows are going to sum to 36. So that means 1 row is 18. And similarly, for columns, you get that each column is going to have a sum of 9. So right now, the row is not very helpful. You can use the columns, it's going to be much more helpful because you can already determine 3 cells, these 3 cells, since they already have one number in each column. So the top left is going to be 6. This cell is going to be 5, and this cell is going to be 1. So that means that the top right cell is going to be 18 minus 6 minus 4 minus 1, and that's equal to 7. And yeah, it looks like a lot of people got E in the chat. Good job.
Nice. Well done. Yeah, I just wanted to make a quick note about a formula William used earlier in the question, which is the sum of the numbers from 1 to 8 is 36. And there are a number of ways to figure this out, but my favorite one is, well, there are 8 numbers, right? We have 8 numbers, and the number in the exact middle of all of this, well, we could write them out just to completely convince ourselves, 1, 2, 3, 4, 5, 6, 7, 8. The number completely in the middle would be 4.5. That is, this is the average of 1, 2, 3, 4, 5, 6, 7, and 8. So their sum is the average times the number of terms, which is then going to be 8 times 4.5, which is 36. Awesome. Yeah. And as people see in chat, I've seen a number of ways to do this, which is awesome. You can count 1 plus 2 plus 3 plus 4 all the way to any n. And these are the triangular numbers, which are a bit of a side note, but fun nonetheless, just like these magic rectangles were. But now we are very bad civil engineers, and we're trying to design a road. But in order to do that, we have some semicircles and the lengths of some line segments, and we want to find the radius of the semicircle. All right, how can we do this? Well, let's see. I think this diagram at first is a little confusing to me, so I want to add some points to make it very clear which lengths are which. Alrighty. Cool. Okay, so this length here on either side is 22. Then, well, we have 12, 2 12s, and a 16 in the middle. What would this length be here? Well, this length would be 2 times the radius of the semicircle minus 22. So this is 2r minus 22 over here. And then, well, I guess I could also find this white length here, or the length between these 2 orange points, to be, well, 22 minus 12, or 10. And that's because we want this length over here, the diameter of the gray semicircle, to also be 2 times r. So 10 plus 12 minus 22, that gives 2r. And so that's how we know that this length over here is 10. Alrighty. And yeah, as I saw pointed out in chat, well, by symmetry, we can just say that this length here is also 10, which is much harder to read 10, but still 10, which means that the total diameter of this semicircle is 10 plus 10 plus 16, which is 36. So it's answer E. Just kidding. We want the radius. It's going to be 36 over 2, which is answer choice C. All right. Yeah, well, let us see if we have been successful in solving it. And we have. And yeah, the answer choice of E is very tricky because it would be easy to, after doing all this work, get 36 and see, oh, it's an answer choice. Awesome. But they want the radius, not the diameter. Don't get diametered, as my physics teacher likes to say.
Sometimes it's don't get radius. Like they're asking for a diameter sometimes, but usually it's the radius. Because like radius is just more relevant.
Yeah.
Matchsticks can be used to write digits as shown in the diagram. How many different integers can be written using exactly 6 matchsticks in this way? So it looks like we're just counting the number of matchsticks, right? How many different positive integers? Oh wait, no. So it's like different positive integers means that they could have more than one digit. So let's look at the one digit numbers for now. 0 is made of 6. Let's just 1 is made of 2. We'll keep that in mind. 2 is made out of 5. 3 is made out of 5. 4 is made of 4 of them. 5 is 5. 6 is okay, so 6 is made of 6 matchsticks. And then I think none of the other one. No, 9 is also made of 6 matchsticks. So we already found 3 single digit numbers. So what about double digit? So that means that we need some digits that are less than 6 matchsticks. So these include any of the other ones here that is not 8. But you also want to see that the smallest number of matchsticks you need to make a digit is going to be 2 for the number 1. So it means that you're not going to use any digit that has 5 matchsticks because you cannot fill in that one more matchstick. So we can also cross out the numbers 2, 3, 5. So now we're just left with 1, 4, 7. And 1 has 2 matchsticks, 4 has 4, and 7 has 3. So if it's a 2-digit number, we can either use a 2 and a 4, like 2 matchsticks plus 4 matchsticks, or 3 matchsticks plus 3 matchsticks. So we can make a 14, a 41, or a 77. And then for 3 digits, you can only use once because you need at least 2 matchsticks per digit. And so that means you're going to have at least 6 matchsticks for a 3-digit number. So you can only use once. And then you can't make any 4-digit numbers. So we have 0, 6, 9 as our single digit. We have 3 more 2-digit numbers, and then we have 1 3-digit number. So wait. Oh, positive integer, so you can't make a 0. You have 2 1-digit numbers, 3 2-digit numbers, and 1 3-digit number. So the answer is going to be 6. Because it's a good thing that 7 was not one of the answer choices, because I did not see positive integers. All right, next question.
Oh, nice. Good catch. Alrighty. The next question is some geometry. We've got a triangle ABC with angle A, the, I don't know, central angle, vertex angle, tip angle. I forget the terminology, but either way,
Vertex.
angle ABC, the vertex angle, equal to 40 degrees. The 2 marked angles, which are angle EAB and DCA, so EAB, that is indeed marked, and DCA, also marked. Good. They are equal. What is the size of angle CFE? The question mark. Alrighty. Well, this seems like it's just going to be an angle chasing question, which is fun. Alrighty. So the first angle we could find is going to be angle BAC, which is, what is it? It's going to be 180 minus 40 divided by 2 because it's equal to angle BCA and the vertex angle is 40. So this is going to be 140 divided by 2, which is 70. Okay, so this is 70 and this is 70. Maybe I'll set the angle that is equal over here to be x so that we can start doing more useful angle chasing. So over here is x, and this green angle that I'm marking will be 70 minus x, and then this red angle that I'm marking will be 140 minus x, and then, okay, because we have triangle DEA or DEA that must add up to 180 degrees, and because BC is a line, well, this orange angle here must be x plus 40. I regret not drawing a bigger diagram. This is becoming kind of cumbersome, I must admit. But, aha, what we can do now is find this question mark angle in terms of x. Well, that's going to be, well, the sum of these two angles here, the other two angles in the triangle is x plus 40 plus 70, which is x plus 110. So this question mark equals 70 minus x. Yeah. And so we know that this angle that's supplementary to the question mark, the one in light yellow, should then be, well, 180 minus question mark, which equals x plus 110. Okay, and I think we're getting close. Yes, we are, because now we can use this triangle that I'm going to briefly shade in to find that, well, what is it? This yellow angle, which we have here, is x plus 110 plus 70 minus x plus x needs to equal 180. So x plus 110 plus 70. Wait a second, something's off. X is definitely not 0. Plus x equals 180. I think I may have made a mistake somewhere because this gives x equals 0, which is definitely false. Do you see what I did, William? Let's see.
Where are you getting the x plus 110 on the right side?
Let's see. So I chased from the 40 down here. We got to set the double hashed angle that equal to x, which gave this green angle FAC equal to 70 minus x. And this triangle here, triangle BAE, gave the angle BEA as 140 minus x because we wanted x plus 140 minus x plus 40 to be 180. And then using line BC, angle FEC, which is marked in orange, is then x plus 40 to get 180. So then,
Wait, so I think
that I'm a victim of a very poorly drawn diagram, which is, of course, my fault. My mistake here. Oh, wait, I'll quickly mention my mistake in case other people are curious. But I thought that this angle was 70, when in fact, this larger angle here is 70. Don't be like me. Properly draw your angle markings. And this will save you sadness, I guess. Okay, wait, William, you said you have another method other than angle chasing?
I mean, I think it's just a shorter angle chase. So this is 70 minus x, right? And this is x. So that means that AFC is going to be 180 degrees minus x minus 70 plus x equals 110. So then the question mark is going to be 180 minus this, so it's going to be 70.
Oh, wow. That was definitely much quicker. Really nice find. Nice.
Okay, anyway, and yeah, the answer is 70 degrees. We got it. It's another geometry question. All right, the diagram shows a rectangle made from 3 gray squares, each of area 25 centimeters cubed, squared inside a larger black rectangle. Two of the vertices of the gray rectangle touch the midpoints of the shorter sides of the black rectangle, and the other two are vertices, two vertices of the gray rectangle touch the other two sides of the black rectangle. What is the area in centimeters cubed? Okay, that is interesting question. So what I do first thing is, because each square has area 25 cm squared, that means that each side is going to be 5 centimeters. I'm not going to write down the units, but we're just going to keep everything in centimeters. And now we know that it's going, two of the vertices are going to be on the midpoint of the shorter rectangle side. So let's just say that this is x. X is half of the shorter side, not the entire side. So, and then next, what you could do, this is also x, this is also x. So I think from now, what I would do is use the Pythagorean theorem. But actually, no, there's a better way. So let's let this be y. Actually, no, I'm gonna let this little small side, this part be y. And then we actually have similar triangles. So this small triangle is similar to this big one because you can use some angle chasing. And this is pretty much like, you'll get a lot of similarity if you have the 90-degree angles. So we have one triangle that is 5yx, and then another one that is like 15, and x. Yeah, so that means that x is going to be 3 times y. X is equal to 3y. So now we can actually write everything in terms of y. I'm going to do that real quick. So we have 3y, 3y, y. So we can use the Pythagorean theorem now because we have y squared plus 9y squared equals 25. So y squared is going to equal 25 over 10 equals 5 over 2. So y equals root 10 over 2 after you rationalize the denominator. Radicalize. And then we can also find the length of this. This is going to be 9y because of our similar triangles observation. So the shorter side length is going to be 6y, and the longer one is going to be 10y, because 9y plus y equals 10. I mean 10y. So the area is going to equal 60y squared, which is actually, we actually did not need to find the value of y because all we needed to know is the value of y squared. 60 times 5 over 2 is equal to 150. Apologies, I don't think you guys can see this. And yeah, the answer is D. I feel like I overcomplicated that a little, but I'm pretty sure the main idea is to use similar triangles and Pythagorean theorem. So next question.
Yeah, I agree with that. That seems like a good way to do it. Alrighty, moving on. We have some 2023 consecutive integers that sum to 2023. This question is out of date. It should be 2024 consecutive integers summing to 2024. But I'm glad it's 2023 because 2023 is odd, which will be important to us later. But either way, we'd start by saying that, well, since we have 2023 consecutive integers that sum to 2023, their average is going to be 1. So we have some numbers before 1 and some numbers after 1. Well, actually, we have 1011 numbers before 1 and 1011 numbers after 1. Effectively, we'd end up summing 1 minus 1011 plus 1 minus 1010 plus blah, 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 all the way to 1 plus 1 plus 1 plus 2 plus 1 plus 1011. Yeah, so some will be negative and some will be positive. But either way, it works out to the exact middle number is going to be 1. And well, since there are 1011 numbers after the 1, the very last number will be 1012. And here we want to be careful to avoid off by 1 errors because, well, 12 suggests an answer choice of 4, but if the answer was actually 1013, then we'd get a sum of 5. Although I guess the nice thing is we know it wouldn't be 1011 as the largest number because 3 is not an answer choice. But either way, being careful, there are definitely 1011 numbers. So the last number should be 1011 plus 1, which is 1012, for an answer choice of 4. And yay. It looks like people are agreeing with me. That means that it is 4. Yay.
Okay, from what I'm seeing, this is more geometry, but an ant is walking along the sides of an equilateral triangle. Speeds at which it travels along three sides is 5 centimeters per minute, 15 centimeters per minute, and 20 centimeters per minute. What is the average speed at which the ant walks the whole perimeter of the triangle? Interesting way, yeah. So it's talking about the average speed. Wait. Oh, I thought there was 3 ants for some reason. Okay, got it. So let's just say that for the first side, it takes the ant t minutes, right? For the slowest side, this side. This is t minutes for the first side. And then the second side, it goes 3 times as fast. So it means it's going to take t over 3 minutes. Right? And then for the last time, it's 4 times as fast. So it only takes t over 4 minutes. And then, so the distance it walks is, so if it takes t minutes to walk this side length, that means that the side length is going to be 5t. Perimeter is going to be 3 times 5t equals 15t. So I'm gonna move this up a little. So after t plus t over 3 plus t over 4 minutes, the ant walks 15t centimeters. So the average rate is going to be 15t over t plus t over 3 plus t over 4. I'm just going to figure this thing out first. This is going to be equal to t 1 plus 1/3 plus 1/4, which is equal to t times 19 over 12. So we have t times 19 over 12, which is equal to 15 times 12 over 19, which is equal to 180 over 19. And that turns out to be answer choice C. So what's nice about this is that the side length of the triangle does not matter because it's equilateral. It's actually not given. So that's why the perimeter is 15t, not some constant. And yeah, it looks like a lot of people are saying C as well in the chat.
Yeah, that was well done. Although one thing I like doing when they don't give a side length is just setting it to something convenient. So when I was writing through this, I just said, well, the side length could be 60 centimeters. Then it takes 12, 4, and 3 minutes to walk around the triangle for an average speed of 180 centimeters over 19 minutes, which got the same answer as you, which is always a good thing. Yeah.
And actually, as Bartu said in chat relay, this is actually the harmonic mean, and you can use this as a shortcut for a lot of questions like this.
Yeah, for sure. Yeah. Alrighty. Oh yeah, actually the harmonic mean is the subject of one of the lessons we here at Daily Challenge teach in, I think, Module 1 Algebra. So that's quite fun. Anyways, now back to Sophia, who wants to write the numbers 1 through 9 in the regions of the shape shown so that the product of numbers in any two adjacent region is not more than 15. And we want to know how many ways there are to do this. Well, the first thing to note is that we have to have 1 in the middle because, well, if we had the smallest number we could otherwise have is 2 in the middle, but the number in the middle has to be multiplied by everything else. And so it'll end up being multiplied by 9, and 18 is bigger than 15. So we're very unhappy if that happens. In other words, 1 must be in the middle. And also note that since 8 times 2 and 9 times 2 are both greater than 15, 8 and 9 have to be on the edges because they can only go multiply with 1 and be less than 15. So I see, yeah, Brandon also noticed this in chat that 8 and 9 need to be on the left and right. And that gives us two options to start with. But maybe let's continue working through things before actually counting how many ways there are to do this. Alrighty. So now we basically have 2, 3, 4, 5, 6, and 7 left. And well, I think, yeah, we definitely want 2 and 3 to be inside our triangles, because if we multiply something that, if we multiply 7 by something that's not 2 or 3, we're going to be bigger than 15. Or actually, we know that 7 has to be multiplied by 2, and so does 6. This is another way of seeing it that 7 times 2 and 6 times 2 are the only possibilities for those. So 6 and 7 must be a rounded 2, because 18 and 21 are bigger than 15. Alrighty. And so that leaves us with 3, which we can multiply with 4 and multiply with 5. Okay. And everything checks out. We get 12, 15, 14, and another 12, which is great. But yeah, now we actually have to solve the rest of the question, which is find the number of ways. Well, we can swap the 8 and 9. We can figure out if we can swap the 2 and 3 positions. And so that gives us 2 times 2 so far. And once we figure out where the 2 and 3 go, we can put the 6 and 7 around the 2 like this, or we could flip them, and similarly down here. So that gives us another 2 times 2 options for a total of 16 options. So yeah, if we draw out our swaps there, we can swap here, we can swap 2 and 3, we can swap the 6 and 7, and we can swap the 4 and 5 as well. And when I say swap 2 and 3, I of course mean bringing the 2, 6, 7 block here and the 3, 4, 5 block up here. So yeah, that gives us a total of 4 possibilities that each have 2 options. Sorry, we have 4 times at which we make a choice between 2 options, which gives us 2 times 2 times 2 times 2, or 16. And it is 16. So hooray. Nice. Well done, everyone.
All right, next question. Some mice live in 3 neighboring houses. Last night, every mouse left his house and moved to one or the other of the 2 houses, always taking the shortest route. The number in the diagram shows the number of mice per house yesterday and today. How many mice use the path shown by the arrow? Okay, that's interesting. So each mouse takes the shortest route. Wait, no, never mind. So hold on a second. So that means that, well, looking at the bottom left house, that means let's say X mice left this house, and then X plus 3 came in this house. And then for this house, Y mice left this house, Y minus 2 come into this house. And then for the last house, let's say Z leaves it, and Z minus 1 come into this house. So this is an interesting question. How many mice use the path shown by the arrow? So this means that X leave this. Wait, oh, hold on a second. Let me think. This is a tricky question, I have to say. Am I reading something wrong here? Every mouse left its house and moved to one or other of the other houses, always taking the shortest route. Wait, what is this always taking the shortest? Yeah.
I think,
are you gonna say something?
Yeah, I think it means that if we have like a total of 8 mice going from this house to this house, they walk like this, and they don't walk like that. So
I don't
basically
know if that's supposed to help somehow.
I think it is, because then we can't have mice, say, going around in circles over and over and over again, and increasing the number of mice using the path shown by the arrow.
Wait, yeah, that makes sense.
Yeah.
Okay, I'm gonna Wait, hold
I
on.
think. Oh, sorry, go on.
Okay, let's say that. Oh, well, what's the house with the most nice? Let's just first say that 3 mice from 8 move to 7, right? So we end up with the 10 on the left. And then you can also every mouse leaves its house. So all right, I think I can. That means that X leave. Okay, so instead of X, I could actually just say 7 mice leave the bottom left house. 8, 5 leave. Wait, no, 8 leaves this one and 5 leaves this one. Wait, am I? I feel like I'm messing up something here.
No, I think this works.
Wait,
At least
can you
I'm
repeat this
working it out
question?
with variables.
I'm messing up something really badly here.
Hmm. I
Hmm.
think I'm not as good at seeing these questions and guessing, but we know net. Well, something we should expect to see net is that 2 more mice leave the house of 8 than end up in it, and so on. Actually, I don't think that ends up being helpful. I do think it's more helpful to write how many mice left the top house to go to the left house, and how many mice left the left house to go to the top house. Because then, yeah, this works, because then we have 2 variables, and one of our equations can be that the sum of the mice going to the right house is 4, and I think that basically gives us our answer, right? Oh yeah,
Wait,
yeah. Oh, go on.
yeah, I think you use your variables better than I did. Yeah, go on.
I see. So yeah, if we say that A mice left the top house, then and going left, then 8 minus A mice will have to leave the top house going right. I agree. I also really like mice problem. And I'm sure Rat Chile also is a big fan of them. Anyways, we also have B mice leaving house 7 and going towards house 8, or I'm just going to call them by these numbers. And so we know that we have 7 minus B mice going right. And so this means that 8 minus A plus 7 minus B equals 4, because these are all the mice that end up going to the right house. And well, with a little manipulation, we end up with 11 equals A plus B. Now, at first I was thinking, how do we find exactly what A is and exactly what B is? We could, because, we could add a variable called C for how many have left house 5 and probably solve it explicitly there. But really, we only want A plus B, since we only want the number of mice traveling on this road, which is going to be A plus B. And so we end up with an answer of B11. I feel like there's got to be like a really quick intuitive way based on the fact that we get net -2 on this house, net +3 on this house, and net -1 on this house. But I can't actually think of this way right now. So I guess we'll have to be satisfied with the variables. Yeah. All right. And it does turn out to be 11. So that's awesome.
Oh, am I gonna avenge myself by doing this question? A regular hexagon is divided into 4 quadrilaterals and one smaller regular hexagon. The area of the shaded region and the area of the small hexagon are in the ratio of 4 to 3. What is the area of what is the ratio of small hexagon to big hexagon? Okay, this is another interesting question. So you'll notice that I noticed that all of these quadrilaterals are trapezoids, right? Because this inner hexagon is going to have side lengths that are parallel to those of the larger hexagon. So let's say that we want to find the ratio of the small hexagon to the big hexagon. So we can actually just find the ratio of the sides and then square at the end. So that's what I'm going to do. Let's say that the small hexagon has, let's say it has a side length of 1. And then the big hexagon can have a side length of x. Because you can scale this question, so you can just assume that this is a side length of 1. This is going to be 1. This is 1 minus s. Oh, you guys cannot see that. 1 minus s. And then I'm going to just label the rest of these s as well. S, S, S. Okay. So now this is 1 as well. 1, 1. Okay. So if we draw out this, all right, let's draw. So now that we made like another, this trapezoid is like nicer because it's a isosceles trapezoid, 1 minus s, 1 minus s, s, and then we want to find the length of this side. So because this is a regular hexagon, we can use the fact that it has 120-degree angles, which are like, so that means that this is going to be a 30-degree angle. So this length is going to be 1 minus s over 2. And this is 1 minus s over 2. And this like segment here is s because of it's a trapezoid. So this entire length is going to be 1 minus s plus s is equal to, oh wait, hold on. No, this is not 1 minus s. This is s minus 1. Hold on a second. This is s minus 1. Let me just fix this real quick.
Cool. Yeah.
S
It
minus
is really
1.
nice that this is a regular hexagon because then we get nice angles and also nice symmetries throughout. Yeah.
All right, s minus 1 over 2. And you'll get that s minus 1 plus s equals that's the whole side length. So this is 2s minus 1. So this is going to be 2s minus 2. So the area of this, okay, so instead, no, actually we just need to find the altitude. So this length is going to be, because of the 30, 60, 90 triangles, it's going to be s minus 1 over 2 times root 3. So the area of this trapezoid is going to be 1/2 of s plus 1 times root 3. And then the area of this one, this second one is, so what you can do is you can see that the altitude of this regular hexagon is root 3 because of this little, you can split this triangle into two 30, 60, 90 triangles, and you'll get that the whole length is going to be root 3. So this, and similarly, this is going to be s root 3 minus root 3. So the area of this trapezoid is going to be 1/2 times s plus 1 times s root 3 minus root 3. So the sum of these two trapezoids is going to equal 1/2 s plus 1 s root 3. And then the area of the smaller hexagon is going to be easier to compute. It's going to be 6 equilateral triangles of side length 1. So that's going to be 3 root 3 over 2. And you want these to have a ratio of 4 to 3. So you just divide this, hold on, this by this to get s plus 1 times s over 3 is going to equal 4/3. So s is going to be, s squared plus s is going to equal 4. S squared plus s minus 4 equals 0. And then s is going to equal, wait, Oh, this is gonna
That
and then
does look
messing
like it
something
ends
up
up
again.
being pretty messy. I saw something in chat that suggests that we should also take advantage of the symmetry of the regular hexagon by reflecting
Oh,
everything
what the?
over that symmetry line.
Oh, I did not see
You
that.
guys are
Oh my
smart.
God. Evan, can you do the next question?
Okay, yeah.
I need a little break. Okay, so
Okay.
yeah, because this actually has a really good symmetry. Uh, I'm not forgiving myself for not seeing that. How do we move this down even? Okay, anyway, uh, because this has symmetry, this quadrilateral is going to equal to this quadrilateral, the two that I circled. So let's just say double this shaded area is just going to be the entire X hexagon minus the small hexagon. So we have that the shaded region to the small hexagon is going to be 4 to 3. But then the ratio of everything outside the small hexagon to the small hexagon is 8 to 3. So that means that the total is going to be 11, say that, and then the small hexagon is 3. So yeah, it's actually 8. It's going to be 3 over 11.
Yay. That was a neat solution. Clever symmetry. I think we have enough time though for one more question about rugby. Also, yeah. Ooh. Let's see. A rugby team is playing some games and they scored 24, 17, and 25 points in the 7th, 8th, and 9th games of the season. Their average point per games was higher after 9 games than it was after the first 6 games. Oh, goodness. And their average after 10 games was more than 22. And we want to know the smallest number of points that they could have scored in their 10th game. Okay. So really, I guess we don't care what exactly they score in the first 6 games because that never becomes relevant. So let us just say that the average of the first 6 games is G. So they could say G, 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 G in the first 6 games, then 24, 17, 25. And well, since their average after 9 games was higher than their average after 6 games, well, we know that the average of these 3 games here will be bigger than G. So 24 plus 17 plus 25 divided by 3, which is 22, is bigger than G. So since we want the average after 10 games is bigger than 22. So we want the average here to be as big as possible. So we shall just set G equals 21. So 21 6 times, then 24, 17, and 25. And we want the average to be 23 at the end. So the average needs to be 23. Average 23. And one way I like doing this is, well, each of these first 3 games is 2 less than the average. So -2, -4, -6, -8, -10, -12. Then -11 because 24 is 1 more than the average. Then -11, -6, which is -17 because 17 is 6 less than the average. And then -17 plus 2, which goes to -15. Wait a second. No, this is definitely not right because that would give
No,
me
Evan.
something way too big.
Evan,
For
the average does not need to be an integer.
That's an excellent point. That's a really excellent point. Thank you, William. The average doesn't need to be an integer. So the average during the first couple of games could be 22, 22, 22, 22, 22, 21. And we just want to make it such that the sum of all of this plus 10th game, x, is greater than 22 times 10, 220. Okay, and this ends up being 22 times 10 minus 22 times 1, 2, 3, 4, 5, which is 22 times 5. Let me cancel that, which is 110. And then we can subtract off. Oh, I want to find a nice way to add this in my head, but that might take longer than actually just doing normal addition. 21, 24, 17, 25. Almost there. 9, 10, 17. 17. 2, 4, 6, 8. So 87. And so 87 plus x is more than 110. So x needs to be bigger. That's not good at all. That's really not good at all. Did I miss 1, 2, 3,
What do you
4,
mean?
5? Because then
87 plus x is greater than
no, I
110,
subtracted in my
so-
head incorrectly. Yeah, that gives x is 20. X is bigger than 23. So x is 24. Nice. Yeah. Perhaps this should be a lesson, unless you're better at mental arithmetic than me, to not do things in your head and conclude about things. Because I concluded, 87, take that away from 110, you get 33. But no, you get 23.
Okay, so if you do not wish to do arithmetic, wait, can you go back to your screen?
Oh, yes, I shall.
If you do not wish to do arithmetic, well, after you do have to notice that the average of the three numbers 24, 17, and 25 are 22. But then you can realize, as on Evan's screen, that the first 6 games can like all be 22s except for one of them. So the sum of these 9 games is going to be 9 times 22 minus 1. So then if the last game was 22 plus 1, then the average would be 22 again. So that would be 23 points. But you want the average to be more than 22, so you can just add one more point to that last game. So you'll get 24. So that's not as much as arithmetic.
Oh, that's a good way as well. I like that. Alrighty. Nice. Well, that was the last question. And the answer is indeed 24. So really well done. All right. That was enjoyable. Thank you all for coming. And have an excellent rest of your evening or rest of your day. Have an excellent time in general. All right. Cool.
All right.
That
Bye,
is
guys.
the hour. Goodbye, everyone.
Bye.
Goodbye. Thank you all for coming.
Rat
Goodbye. Oh, and Andy, for the last question, it can't be A because that would make the average too small. All right.
Yeah.
Bye. Goodbye, everyone. Thank you all for coming. This was enjoyable. And thank you for such active participation.